Starting system. Solenoid. The solenoid-actuated starter is by far the most common starter system used. A solenoid is an electromechanical device that uses the movement of a plunger to exert a pulling or holding force. As shown in figure, the solenoid mounts directly on top of the starter motor. In this type of starting system, the solenoid uses the electromagnetic field generated by its coil to perform two distinct jobs. The first is to push the drive pinion of the starter motor into mesh with the engine's flywheel. This is the solenoid's mechanical function. The second job is to act as an electrical relay switch to energize the motor once the drive pinion is engaged. Once the contact points of the solenoid are closed, full current flows to the starter motor. The solenoid assembly has two separate windings, a pull-in winding and a hold-in winding. The two windings have approximately the same number of turns but are wound from different size wire. Together these windings produces the electromagnetic force needed to pull the plunger into the solenoid coil. The heavier pull-in windings draw the plunger into the solenoid, while the lighter gauge windings produce enough magnetic force to hold the plunger in this position. Both windings are energized when the ignition switch is turned to the start position. When the plunger disc makes contact with this solenoid terminal, the pull-in winding is deactivated. At the same time, the plunger contact disc makes the motor feed connection between the battery and the starting motor, directing current to the field coils and starter motor armature for cranking power. As the solenoid plunger moves, the shift fork also pivots on the pivot pin and pushes the starter drive pinion into mesh with the flywheel ring gear. When the starter motor receives current, its armature starts to turn. This motion is transferred through an overrunning clutch and pinion gear to the engine flywheel, and the engine is cranked. With this type of solenoid-actuated direct drive starting system, teeth on the pinion gear may not immediately mesh with the flywheel ring gear. If this occurs, a spring located behind the pinion compresses, so the solenoid plunger can complete its stroke. When the starter motor armature begins to turn, the pinion teeth quickly line up with the flywheel teeth, and the spring pressure forces them to mesh. Starter relay. Relays are the second major type of magnetic switch used. All positive engagement starters use a relay in series with the battery cables to deliver the high current necessary through the shortest possible battery cables. This figure shows a typical starter relay. It is very similar to the solenoid. However, it is not used to move the drive pinion into mesh. It is strictly an electrical relay, or switch. When current from the ignition switch arrives at the ignition switch terminal of the relay, a strong magnetic field is generated in the coil of the relay. This magnetic force pulls the plunger contact disc against the battery terminal and the starter terminal of the relay, allowing full current flow to the starter motor. A secondary function of the starter relay is to provide an alternate electrical path to the ignition coil during cranking. This current flow bypasses the resistance wire or ballast resistor in the ignition primary circuit. This is done when the plunger disc contacts the ignition bypass terminal on the relay. Not all systems have an ignition bypass setup. Some vehicles use both a starter relay and a starter motor mounted solenoid. The relay controls current flow to the solenoid, which in turn controls current flow to the starter motor. This reduces the amount of current flowing the ignition switch. Basically, all the different starting systems in use today fit into one of three categories: the solenoid shift with relay, or positive engagement with relay.